Alrighty, in this video I want to go ahead and constrain the player to the level. So we could certainly accomplish that by placing objects. For example, if we don't want the player to go to the left and fall off, we could place a bunch of these boxes or these squares up really high so the player has no way of falling off the level. But what if we also wanted the player to die if he hit the bottom of the level? Or what if we wanted to have nothing happen? For example, if he hit the top of the level. What I want to do is I want to create a nice little component that will allow us to express these different bits of behavior on our player in a really simple, straightforward way that doesn't require us to do anything hackish like try to build a wall that the player can't jump over. Because inevitably a player will find a way to jump over it and then complain that your game is broken. So fortunately, we already have a camera bounds that is a box collider 2D and defines the extents of our level. So what I want to do here is I want to create a new component that I can attach to the player that will use the camera bounds plus the addition of some configuration in order to describe the behavior I want to happen when a player reaches one of these bounds. Alright, let's go ahead and jump into Visual Studio. I'm going to open up my code folder and I'm going to add a new class. And I'm going to call it player bounds. I'm going to take off the namespace declaration and I'm going to go ahead and have it implement or inherit from mono behavior because it will be a mono behavior and it's going to have some methods in it. So what I want to have, or it's going to have some methods and it's also going to have some public properties. But first, before I create the public fields on this class, I want to go ahead and define an enumeration. And the enumeration is going to represent the three things that I want to have happen if the player hits the bounds of the level. I want to be able to have it do nothing. I want to have it constrain the player to that bounds, or I want to have it kill the player. So I'm going to say public enum bounds behavior. And so for the first parameter, or for the first method, I'm going to say nothing. So we'll do nothing if the player reaches the bounds. The next one I'm going to say is constrain, which will constrain the player to the bounds. And the final one is I want to go ahead and say kill, for killing the player. Okay, so let's go ahead and first of all, let's get some private fields out of the way. Or let's do our public fields first. Let's say public box collider bounds. And that's going to be a reference to the same box collider that we use for our camera bounds. Next up, I'm going to say public bounds behavior above behavior. Or let's just say call it above. Above is good. Public bounds behavior below. Public bounds behavior left. And public bounds behavior right. So these are going to be the options that you have for when the player hits any of these bounds. Next up, I'm going to need some private fields. First of all, I need a private reference to my player object to know that if he's dead or not. Then I'll need a private reference to the box collider 2D. And this is going to be the box collider attached to the player. We need this information for our constraining to know if a player is hitting the bounds or not. Then let's go ahead and write a public void update method. And what I'm going to first do is I'm going to say if player is dead, return. Now people who are paying close attention might realize that I have not actually assigned player to anything yet. So before we finish off the update method, I'm going to say public void start. I'm going to say player equals get component player and box collider equals get component box collider 2D. So now that I have that all done, these methods will no longer throw exceptions. So what do I need to do here? Well, first of all, I need to know if the player is hitting any of these bounds, and I can do that with some simple math. The first thing I need to do is calculate the size of the box collider. And that's actually pretty straightforward to do. We can access its size, and then we can multiply it by its scale. Now remember, our box collider will have a center value and a size. However, I'm just going to assume the box collider is in the center of the player. So let's go ahead and say var collider size equals new vector2 box collider.size.x multiplied by transform local scale x, comma, box collider size y multiplied by transform local scale y. So this will give us the amount of units that our collider is. All right, so now that we have that, we can go ahead and also divide this by 2, because we're going to be mostly interested in the collider size divided by 2. So we'll just, instead of saying a divide equals 2 at the end, we'll just add a divide 2 at the end of this new vector 2 instantiation. Now we have to detect one of the 4 cases if the player is trying to go above, below, left, or right of our bounds, and then we want to apply different behaviors based off of those. So what I'm going to do is I'm going to write 4 if statements, and those if statements are going to invoke a method that I have yet to define. So I'm going to say if transform.position.y plus collider size.y is greater than bounds dot max.y, then apply bounds behavior above, and then I'm going to pass in the new vector 2, and I'll talk about this in a second here. It's going to be a new vector 2 of transform position x followed by transform position x minus, or sorry, transform position y minus collider size dot y. Then I'm going to say if transform position y minus collider size dot y is smaller than bounds min y, then apply bounds behavior passing in below and a new vector 2 of transform position x followed by transform position y plus collider size dot y. Then we want to say if transform position x plus collider size dot x is greater than bounds max x, then apply bounds behavior. This is going to be to the right because this is in the positive x direction with a new vector 2, and the x position is going to be transform position x. We're going to want to do minus collider size x. And then we're going to want to pass in a transform position y. And then if transform position x minus collider size x is smaller than bounds min x, then we'll say apply bounds behavior left new vector 2 transform position x plus collider size x, comma, transform position y. Okay, so the apply bounds behavior method is kind of an abstraction of the 3 kinds of things that I might want to do with this information. I might want to say I want to constrain the player, I might want to kill the player, or I might want to do nothing. As far as doing nothing goes, I could, instead of having an if statement in the apply bounds behavior for nothing, I could modify each one of these if statements to include a check to see if that particular bounds needs to do anything. So for example, on our above, I could say if above does not equal nothing, and. So if above does not equal bounds behavior nothing, and the player is above or hitting the above bounds, then what we want to do is apply the bounds behavior, and we want to pass in the position that we would need to reset the player to if our behavior is constrained. So this is below, so I'll say if below does not equal bounds behavior dot below, or what? Derp, nothing. If below does not equal nothing, then do that. If this is going to be the right, if right does not equal bounds behavior dot right, wow, bounds behavior dot nothing, derp, and that. And finally, if left does not equal bounds behavior dot nothing, and. All right, let's go ahead and implement our apply bounds behavior method. It's simply going to be a private void apply bounds behavior vector 2 constrained position. Then I'm going to say if behavior equals kill, then level manager dot instance dot kill player, and then return. Otherwise, the behavior has to be constrained, in which we set transform.position equals constrained position. So now it should be a little bit more clear why we passed in this vector 2 here, because we need this vector 2 to know where to reset the player's position if he tries to go past the bounds. All right, let's go ahead and exit full screen, jump back into Unity, and see this code in action. Let's select our player, let's add a component, and let's say constrained or player bounds. That's the component we're adding. The bounds that we're adding are going to be the same thing as camera bounds, so I can just click and drag camera bounds onto bounds. And then we can choose our behaviors. So the above behavior will be nothing, the below behavior will be kill, the left will be constrain, and the right will be constrain. Now that I made this change to the player prefab, I'll want to go ahead and scroll all the way to the top and hit apply. Now that I've done that, let's hit play and see what happens. It looks like I got something backwards here. Definitely seems like I got something backwards. Let's see if I die. If I try to go below, and then we'll worry about our constrained behavior. Okay, I need to get rid of these buzzsaws. This is just making it impossible to test anything. Maybe they would be a good game mechanic, or they are a good game mechanic, but we're just going to remove these insta-kill buzzsaws from the game so that it's a little bit easier to test. And again, we will be actually making a real level here very soon, where we'll actually pay attention to that sort of thing. Okay, let's go ahead and die, and we do die. So our below bounds work. However, our left bounds seem to not work. They seem to only be applying if I'm moving to the right. That's kind of bizarre. Let's look at our code and see what could be going on. So our left, if our left bounds does not equal nothing and our transform position x minus our collider size x is smaller than our min x of our bounds, then apply bounds behavior. I'm going to put a debug log out here. I'm going to say debug log bounds hit. Then I'm going to come back here and hit play, and I'm going to see if we're even hitting our bounds. Which, interestingly enough, we're not. Oh, wow, I know what's wrong. It's our scale. It's our scale of our local scale x. Because we're flipping our scale, we're running into an issue where that's not going to let us go forward. So what I'm going to do, instead of saying box collider.size.x multiplied by transform local scale x, I'm going to say mathf absolute value transform local scale x. And I'm going to do the same thing for our transform local y. Alrighty, sorry about that, guys. Come back here, hitting play. We are indeed pushed back, but we're pushed back a little too far, unfortunately. We are hitting the left-hand side just like what we should be, but when we get pushed back too far. And that's probably because when we apply our left bounds, I am not setting the correct vector 2. And that's probably because I need to take our bounds position x and our transform position x. No, what I want to do is I want to set the bounds position x plus the collider size x. So bounds.bounds min x plus collider size x should give us the proper place to be pushed back to. And now you see, there, that looks good. I like that. There's no longer any jumping or nastiness involved with pushing up against the left-hand side. And that means that we will need to replace all of our transform position x's with our bounds min x's and max x's. So this is actually going to be bounds max x minus collider size x. Then this one, our below, is going to be bounds min y. or sorry, it's going to be transform position x, and then we're going to say bounds min y plus collider size x. And then our final one, our above, is going to be bounds max x minus collider size y, or max y. Alrighty, so that should give us the proper values to constrain our player's location. Yeah, sorry about that. Passing in the transform position x minus collider size x doesn't actually make any sense. We want to pass in the maximum value that they could be at that moment, and then we want to offset that maximum value that they could be at that moment by the size of the player's collider. Okay, so now that we have those two bits done, or those two fixes done, we now see that we are indeed constrained to the left-hand side of the screen, and it looks good because our camera constraints and our player constraints are the same value, which is exactly what we want to have. And then you'll notice when I fall down, I die. And that's exactly the behavior that I'm looking for. All right, I think that just about wraps this video up, and we'll see you guys in the next one.